Well, hello there, you guys. This will be my first video on Star-CCM Plus, and hopefully I will teach you new things that you don't know about Star-CCM Plus. And if you're new to Star-CCM Plus, this is the right video for you. I will pretty much go through the CADs and how to draw bodies in Star-CCM, and how to create regions, create mesh, and how to see your results and all that. I will go case by case, the things I did throughout my university years and what I recently did. In fact, I recently did a case in which I had to analyze a heat transfer from two CPUs and dissipate that heat throughout the system. It was water cooling, and it was kind of tough, to be honest, but at the end I did it, and I will show you how to do it. And here you can see the case here. So pretty much this is the cross section. You're seeing this from the top. This is the top view, and this is the copper pipe, and water flows through there. And these are the CPUs, these little square things, and these are the bases on which the CPUs lie. And the overall view will be like this. The thing you have to think before starting a simulation is that um, how can I create these regions in order to run the simulations? For example, you're gonna have multiple regions in this case. So you're gonna have a region. By region, I mean regions represent the the places where the physics will be. Okay, I'm not sure if I'm clear there. So let's say, for example, this is CPU one, right? It will be out of aluminum or silicon, let's say. So it has its own regions, its own physics. The copper pipe has its own physics, and the water through it will have its own physics. So there will be, how many regions will be there? So there is one CPU, its base, two copper pipe, three the waterway, four the base, and this second CPU. So there will be six total regions where the physics will vary. Okay, so that's what I mean by region. So let's start. In order to start, you have to go top left. It says create a new file. The shortcut is CTRLN. So you just click here. You can either choose serial or parallel. I'm not exactly sure what's the difference. Okay, I mean, I like what I read was serial is good for mesh cell numbers below like 10 million, and parallel is good for mesh that has more than 10 million cell numbers. So you can choose your processors, the number of processors. So my core has about 12 CPU processors. So I generally choose six. It's not gonna be that tough. You will need a parallel and demand key. We'll just type it there. Of course, I will blur it here. So you just say OK. It takes a while to open. Now we can begin with the geometry. Okay, so you just open this tab. You right click and then say new. This is where we will draw our bodies. Okay, you can start with XZ plane. You right click again, say create sketch. So on the left, you will have these things that we will use. To start with, we will adjust our sketch grid spacing. Grid spacing means spaces between these. Uh, I mean, it's a square, right? Spacing means uh, like the dimension of one square. So our dimensions will not be that big, so we can just make it 1 millimeter. And then grid number of plane grid divisions is when you zoom in to the sketch and you will see that this one square is divided. Okay, we can either increase or decrease it. Let's say 10 and see the difference. So we zoom in, right? So there will be 10 sections here. 1, 2, 3, 4, like 10 squares, right? So one square will divide into 10 horizontally and vertically. We don't need that much. Let's just say 5. I mean, divided by 5. See, now it decreased. Okay, that's set. Now, let's say you accidentally just did this, okay? Like it moves around. And you want to see normally. So, like, all you want is a normal plane, the plane to look at you. And you just go to this and say normal to sketch plane. And so we'll just give you the normal look. And you can either not display, like these are the options. You can either hide it, show unbounded grid and all that. But we want the grid to show. And let's start our sketch. The dimensions of the first CPU will be 1 centimeter by 1 centimeter. So you can say, let's start with this. Just put it, okay, just put a line and say, so you can either work with meters, millimeters, centimeters. I'll just work with millimeters. It's easier for me. I'll say 5 millimeter. Okay. Oops, sorry. Let's not say okay. You can edit there. And if you say okay, it ends the sketch. That's what I did all the time. Just keep that in mind. It takes a lot of time if you don't. So it's gonna be 1 centimeter, right? Let's say there. I like it to be symmetric. That's my personal thing. You can just do it in like, you can do it anywhere. Doesn't matter. So yeah, that's that. So 5 millimeters there. You can select this, okay, and then you can just do that. So it's easier. Well, this way it was easier for me. You can just do it line by line. Doesn't matter. What's bad about this way is that you have to delete the lines. Otherwise, like extrusion will not happen. The system will give an error. So you say, okay, that's our first sketch. That's done. In order to extrude, you right click. You can rename this CPU1 sketch, right? Yeah. And then you can extrude this, where you right click and then you extrude. Okay, so extrusion, it's in meters. Again, you can work with millimeters. Oh, I want 10 millimeter or 1 centimeter. Let's use 1 centimeter extrusion. Let's go with 1 centimeter. Yeah, it wasn't 1 centimeter. It was 5 millimeters. Um, okay, let's go through these. You can make it a sheet body. Sheet body meaning it won't have a volume. Okay, like see, it won't have a volume. It's just the sheet body. But the difference you will see now, if it's solid, then it caps off and it won't be a sheet body anymore. The method, you can say if you have like more than one body, and it will show here. You can say up to the face of a specific body, since there's no other body here. Um, you can't use this. Blind meaning the amount of extrusion you want. You can like can adjust your dimensions here, your extrusion dimensions. And direction type, it can be normal. So the normal is this way, right? Like up here. You can reverse this, the underside, and you can specify it like the directional vectors. You can just specify that. We don't want that though. You can add a reference axis, in fact, but um, I haven't done it yet, so we don't need it in this case. So we'll just say normal. We'll in 5 millimeter extrusion, draft, none, merge. In some cases, if you have more than one body, you can merge these to make one total body, okay? I'll show you that, but we don't want this to merge. Imprinting is another thing. I'll show you that as well. So we say body interaction none. You can see the preview, or you don't want to see the preview. That's your choice. We'll say okay. So this is our body. You can see the body groups up here. Let's rename this so we won't confuse the bodies. This is CPU 1. Yeah. Okay, so we want the base to be right underneath the CPU. So what we do is you click here, right click, and then say at face center on face. If you say at face center, it will take you to face center. Okay, start our sketch. So what we want is a let's say 1 centimeter from here, 1 centimeter, say 5, let's say 1 centimeter here, 2 by 2, let's say. So again, we do this, click there, click, oops, I failed. Let's do that. There we go. This is our second sketch. We can rename it base 1 sketch. I usually don't rename these, but it's a better habit if you just rename these. Let's say the base is 3 centimeters, 3 millimeters, yeah. By the way, if you don't see your objects at all, you can just click this small button up here to straight up zoom you to the place you are interested in. This is the button if you want to make the scene transparent. See, we will use this later on again. We don't want this object to merge. So if you merge these two bodies will be merged into one body. That's what it means, merging. I think this was, let's make it 5 millimeters, yeah. And then we can make this exposed diameter, exposed parameter, which meaning that you can later on easily access to this tab where you can easily change these parameters. Let's say this exposed parameter, base 1 extrusion. We'll see this later on. Let's say okay, we're done. So here's your body, second body. Let's say base 1. That's it. Now we have two body groups, one CPU, one base. Okay. So now we need the pipes to go through the whole thing, right? Okay, so here's the image. So we want this, right? We'll just try to construct a similar thing. So we'll start by selecting a face. I want this face. Okay, you right click here, you say create sketch at face center. Let's normalize this so we'll just see the image. If you say like I cannot work like this by this orientation, so you can fix the view by selecting this photograph machine. You select views, you say positive. I mean, the way this works is that, so just go over like this, right? You look at this orientation, right? Not according to this. So when you look at the image like this, the X points towards you, right? So either out of the image, the positive axis is this one, which means the positive axis is towards you, and if it's not, it's the opposite, like that, okay? Anyways, so you look at the orientation, you go here, you save views. Since axis towards you is positive, the X is pretty much the rotation axis, right? I want Y to be up, like that, okay? So there it is. We fix that, okay? You get, again, you can select the grid spacing and all that. Okay, let's start with these. I think it was about 7 millimeters from the center, okay? Again, it's in meters, you can just type 7 millimeters, the same thing. Again, let's make it, how much is this? Let's make the radius 2 millimeters, okay? You can click on it. Again, what you can do is just specify, okay? Just do that. And then the radius, we want it to be 2 millimeters. There you go. So we're gonna rotate this, okay, around this thing. How we gonna do that is that, oops, again, you can fix it if you want. I'm not gonna fix it. We need a construction line in order to revolve this thing. Okay, so just put one construction line from the origin. You right click on it, you say set as construction. It doesn't have to be here, it can be here. The important thing is to specify the axis on which it will rotate on. So let's make this one, just to make it clear, let's just make this as a construction line. We have to delete this in order to revolve, otherwise it will just give you an error. Just select OK, select the sketch, say rename copper pipe 1. Let's say that, okay, doesn't matter. Then you say revolve. See, construction line is here, it just revolves around it. And then we don't want it to merge, we want it to be a solid body. Make it 180 degrees. If you have more than one construction line, you can always choose it like here, okay, doesn't matter. One way, you can make it two-way symmetric, so if it's gonna be like that. So here's your plane, right? It's gonna be symmetric about this plane, the face you chose. And then you can say two-way symmetric. You can just play with these numbers. So 180, I can make it like 100 degrees, and it will act according to that side. On the other side, you can make it, let's say 120 degrees. Just one way, okay? So that's it. We don't want any body interactions. We don't want the bodies to merge. We say okay. So here's our body. You can see the body here. Let's say copper pipe 1. Yeah, okay. Now, again, we want a waterway. It's going to be a pipe, right? Okay, so we want a waterway through that. So we want to sketch on this, on the pipe you just did. What we can do, so I cannot select it, right? What we can do is that we can hide this face, right click hide, and then what you can do is that this color scheme can change with the bodies you generated. Just click on this, and then the third option here, okay? And then you'll see the bodies according to their color groups. Again, so I want to start a sketch here. What you do is right click again, create a sketch at face center, you normalize it. Let's make the thickness of the copper pipe 1 millimeter, okay? So from here to here, it will be 1 millimeter. Also, if you're not sure, you can always measure, okay? So just go in, you can measure it, okay? Yeah, it's about 2 millimeters, 1 millimeter, yeah. Okay, so that's that. Now, what we're gonna do is that, again, say revolve, construction line. Remember the construction line we did the previous sketch. You say that. Oh, see, you know why it's not revolving? Because there are extra lines involved. I think. Let's see. See the mistake we did. Okay. I don't think there is any. Okay, let's see. Let's say okay again. Let's say revolve. Construction line. It's interesting. I'm not sure where we did it wrong. I think we need a construction line. It used to work, but well, I guess it's not working. So we said 7 millimeters, right? Let's set it as construction line here. Right click, set as construction, delete that. Alright, and then evolve this, evolve 180, right? Yep. So this will be our body. Let's call this waterway 1. Okay. We have our copper pipe, we have our water wave. Okay. So now, if you want to see the space, just say right click here. It will show you all of the faces you have hidden, or the bodies. Okay, so yep, there it is. So let's continue with the second CPU on the base. With, let's say, create a sketch on this face. Okay. So again, you choose that. This is important, which way we're going to go. And then there will be a space between these two, about, let's say, 2 centimeters. Okay. Well, let's say 1 centimeter for the sake of simplicity. So the base is bigger than this base over here. Let's say about 2 centimeters. Okay. 2 centimeters here. Again, you can just set the length there. So the shape was like this, right? It's about like, I think it was 1 centimeter here, 2 centimeters here. I'm not sure, we'll see. You can just set up numbers, doesn't matter. Yeah, I think it was 1 centimeter. Yep, 1 cm. And then let's go down by 12 millimeters. And then go about 3 millimeters, 3 centimeters, I mean. And then go up again. Go right all the way down. I think it's all out there. And yep. Oops, well, not there, but I didn't do these 1 millimeter. Okay, what I can show you here is that, let's say this is, oops, let's say this is off, right? Okay, so you can't always work with these grids, okay? So the lines can be off. If you want this to be perpendicular to this line, what you can do is that you press and hold Control button, select these two, select this and then this line, and say apply a perpendicular constraint. And there it is. If this line is changing according to this line you did, you have to set some fixation points for this line, okay? For example, just make this and this parallel to each other, these two lines, and this won't move, but this will move since it is not fixated to any other line. What was the length of this? It's 12 millimeters, right? Let's go in. Oh, oops, I didn't. So this will be 1 centimeter. Let's go down. Yup, exactly. And then let's do the other 1 millimeter. 1 millimeter, right? Yep. Okay. And then 12 millimeters. Put that. Okay. Well, something I did wrong is that we had to do the CPU first. Well, that's fine. It's okay. Delete this. So the sketch is on this plane, right? According to this face, the face of the CPU. What we can do is change that plane on which it is based upon. So it's on this face, right? You can just switch it there, and ta-da! It's on the level of this plane. Again, you can extrude this. Yeah, it has to be reversed. Let's say reversed. How thick was this? I think we did it like 3 millimeters. Nope, I think we did it 5 millimeters. Let's see. Yeah, I think it's about the same. Oops. We don't want anything to merge. Okay. Also, so I'm not sure about the dimension, right? Just click on the edge of this, say properties, and you will see the length. So the dimension is 5 millimeters. Yeah, we did, right? Okay. So let's put the CPU on this thing. Again, right click, select that face at face center. It was 1 by 1 square. 5 millimeters. Oops, well, we can say that. Alright, press OK. Now, let's extrude this again. Extrude, extrude. We want this to be, I think it was 3 millimeters, right? Yeah, we don't want it to merge. Let's make it 3 millimeters, okay? We have to update this, and then make this 3 millimeters too. Update. We want these pipes to go through. I think we kind of have to fix these. Yeah, let's fix it just to be sure. Let's see. Yep, now it will go through. Let's pull these up again. You can do this. Right, that will go through as well, okay? So there we go. So again, we say we have to hide this, okay? Let's go with copper pipe first. Say create sketch at face center. It will be 4 millimeters, so a 2 millimeter radius, and we have to extrude this guy. Let's cut it down. We don't want it to be merged. 6.5. 6 is fine as well, but I just want this portion to show. Okay. Okay, I can show you the method of up to face method. So your sketch is over here, right? We want that sketch to be extruded up to this face. So see, it ends at this face. I don't want that. I just want it to pop out a little bit. So okay. We want the same thing. Okay. Oh, okay. There we go. Let's create a sketch at face center. What you can also do is that you can project to sketch, okay? So now we see the outline for this pipe, this sketch. But the problem is that since this sketch is dependent upon this body, sometimes when you want to make changes, it becomes difficult since while making changes, this sketch is affected as well. So the whole thing changes, okay? The whole body you create from this sketch changes as well. So be careful with that. So hence, I'm going to delete this and just make my own sketch, which is 2 millimeter in radius, okay? And then extrude this as well. Not merged, 6.5 centimeters. Okay. Yep, there we go. Now, okay. So since these are part of the copper pipe we have here, okay. These are all copper pipe, okay. We can merge these together to result in only one body, okay. We only need one body because they will have the same physics, the same region. Okay, so what we have to do is that we have to select these two copper pipe as well. Okay, select all of them. Then say unite. Let's do it like this. Okay, copper pipe, this and this. Okay, Boolean unite. Okay, there we go. So in Boolean, unite, what unite does is just merge these bodies. These are two bodies to be merged with this, okay? Target body, meaning these two will be merged with this body, okay? And so now look at our copper pipe. It's the whole thing. Let's rename these as well. This is CPU2, I forgot. And then this is base 2, okay? Alright. So we haven't done that. Now let's hide this copper pipe, okay? And just right click and say hide. Or what you can do is that we only want to see waterway right now, okay? So what you can do is just show only this and it will show this part only. But okay, now if you want to see all of the bodies, just say that and it should show you. Okay, show faces as well. Now waterway. Again, we have to extrude this. So the waterway will be whole inside the inside the copper pipe. Okay, so it will have the same length. So this was 3 millimeters, I suppose. So the radius is 0.5 millimeters. And then let's extrude this as well. 6.5 centimeters. I don't want it to be merged. Okay, and then do the same thing to this side. At fate center, 1.5 millimeters. Say OK. Right click, extrude, 6.5 millimeters. Okay. Oops, not millimeters, centimeters. Yeah. Okay. Again, let's merge these. How can we do that? Just click on waterway, body 10, body 9, unite. That's it. Okay. So let's see all of the bodies now. You have to subtract some things from each other, okay? First, let's subtract copper pipe from the bases. So base 2 minus copper pipe, subtract. Keep the two bodies, we need pipe to assign a region to it. And then base 1 minus copper pipe, subtract. Keep the two bodies again. You'll see why we're doing this. Okay, this is important to create interfaces between the regions. What's the interface? If you may ask, an interface is information that will be transferred between the boundaries of two regions. Okay, so there's region 1 and then region 2, the base. So information must travel between each other. That's done with an interface. So if we only see base 1 right now, what we will see is this. So we have subtracted the copper pipe from this region, okay? Now we must subtract the waterway from copper pipe, again to create an interface between two regions. So we say copper pipe minus waterway, we say subtract, and then we want to keep the tool body again. Let's say okay. So here it is. So let's just see the copper pipe only, show only. Now there's a hole inside it, okay? The operational steps are important. Like steps I took is how it should be. I mean, you cannot initially subtract waterway from copper pipe and then subtract copper pipe from these bodies. Otherwise, something different will happen. You have to think about this before. I mean, it's kind of a trial and error thing. You have to try. It's okay if you make errors. Just keep on trying. So that's it, I think. We did all the things. Oh, we didn't imprint. Okay, the important thing our imprint is that imprinting in CAD allows the program to understand the contacts between each body. Okay, so while you're making regions, the program will automatically create interfaces according to contacts made in the CAD profile. So we will assign interfaces by imprinting the bodies to each other. Let's say, so we have to imprint CPU1 to base1, okay? And that way, the program will understand that there's a contact between these two objects, bodies. So it doesn't matter which one you choose first. This one, I want these two to be imprinted. Say OK. And then I want CPU2 to base2 to be imprinted. So the imprint, you can see the imprinting surfaces. You can see that here again. So that's where the interface will be. And then I want a contact interface between copper pipe and the base. Let's start with base 1 and copper pipe. Imprint these two, and then let's see so that's imprint 3. Okay, that's the contact 3. And then I want a contact between base 2. Imprint that as well. So let's see that again. So there it is. That's where the contact is. And then I want contact between copper pipe and waterway 1. Again, you imprint these two. Alright. So there it is. See, there's a contact between those two. Okay, let's update CAD. We are pretty much done here. All we need to do is assign inlets. You can do this by splitting by patch after the CAD, but I will show you that too. Let's rename this to, this will be the outlet. That's how I did it. And this will be the inlet. Okay. You split these surfaces to assign boundary conditions. And later you will see that. So we're done with the CAD. Now it's time to create parts and then create regions and then create our mesh and we will be done. Now there are a few procedures that you must go through while creating a simulation, okay? First, right click this, say new geometry part. This is where transition to simulation occurs from CAD to simulation. So you click on this, tessellation density, I generally do it fine or very fine, let's do it fine. What this is about, it's kind of the resolution quality of your CAD. I think something like that. So let's just click OK. So the groups you have created in CAD, so you have your bases, your copper pipe, your CPUs, will be transferred here. If you want to see these parts, go up here. You can say geometry, or you can go down to scenes, right click, and then say new scene, geometry. It's easier from here, just click that. You may sometimes not see the geometry. You can right click, apply presentation, right click on the scene, and then say geometry. Alright? Now, if your CAD is complex and you want to see the regions clearly, what you can do is go down to scenes, geometry scene, geometry 1. Click on this, okay? There should be a tab called color mode, and just change that to distinguish regions. Nope, distinguish inputs. There you go. You can use distinguish regions after you create the regions, so you will have your multiple regions here. And here's the important thing. The imprinting we have done in the CAD model here is transferred here. And here's why it's very easy to make interfaces now. All you have to do is click a part, or you can Control, hold Control, and select all of these. Say, right-click one of those, and say assign parts to regions. So region is where the physics occur, okay? You may have a volumetric mesh, a body. So if you have that, you're not supposed to assign a region to that. So since it won't have a physics to it, okay? I'll show you that as well later in the simulation. And we want region for each part, and we would like a boundary for each part surface. And boundary mode interfaces from contacts will be made. So here are the interfaces. So I click apply, and here are the interfaces. Now let's create some physics, continue for these. The physics, there will be the physics for CPU1, CPU2 will be the same, we will use the same physics. And also let's make it a steady simulation for easier simulation run, for a better simulation runtime. It will be three-dimensional, steady, it's going to be solid. And then we need coupled solid energy. Constant density, the density of the objects will not change. So let's say CPU physics, or we can just say CPU, okay? And then let's go to models, change some things up a bit. There will be silicon, so just right click this, say replace with, and then go to solids, let's type silicon. Alright. So what's the thermal conductivity of silicon? It's 125, 124. You can change it here. You can change various things. You can change the density, specific heat. But I did not touch these. You don't have to for this case. And you can put initial conditions, such as we want this initially to be 35 degrees Celsius. You can write it in kelvins or in Celsius. I haven't tried Fahrenheit. Let's try Fahrenheit. Yeah, I think it works. Yep. Well, I want Celsius, so 35 Celsius. We need one more continua. You can just copy this by dragging it right below it. And then let's rename this to bases, which will be out of aluminum. Like, we don't need to select models. We only need to change the solid. Again, say replace with. Let's go with aluminum. Aluminum, pure aluminum, why not? And then let's assign thermal conductivity to these. Since normally pure aluminum is not used, generally alloyed aluminum are used. So I would like a thermal conductivity of 177 for this. Now we need a copper pipe. Again, just copy this. Let's say copper pipe. Alright. Now, the initial temperatures are there, okay. And then I would like replace with what you can do is that well, that's fine, whatever. I mean, you can change all of these. It can be aluminum again, or you can change these to the properties of copper. It will be the same thing as copper. It doesn't matter. So let's write copper, solids, copper. There it is. Now it's copper. I think it had about a thermal conductivity of about 400. Let's make this 400 straight. Okay. I'll also save this. Now we need a continua for water. Physics continuum. Again, select models, three-dimensional, steady. This will be liquid, coupled flow. You can choose segregated flow as well for better simulation time. Constant density. It will be laminar. We won't be assigning super high velocities. Coupled energy as well, since we're analyzing energy as well, heat, temperature. H2O, it's automatically H2O, your default choice is H2O. Let's assign static temperature of 35 Celsius. Reference values, we don't have to change those, those are fine. Now we have to assign these to the regions we have made. So physics continuum, we want this to be in basis. Base 2 is the same as this. The copper pipe will have physics continuum of the copper pipe. Oops, I spelled this wrong. The R is missing. So that's that. CPUs, physics continuum, CPU. And then the waterway will be physics 1. Let's rename this 1. Alright. So the thing I didn't show you, I forgot, is you can split by patch to assign surfaces. So waterway surfaces, since we have assigned these in the CAD file, you can see the two surfaces we have assigned, inlet, outlet. But you can do these here as well by just right clicking this and splitting by patch. So you have your surfaces there and there, okay? You have your surface here. You can just rename this and assign different boundary conditions for these part surfaces, okay? Let's assign one, just for the sake of it. Let's select CPU2, surfaces. This is our CPU2, split by patch. Let's name this surface as top of CPU. You click create, and your surface is created. And then, since we have already created a region for it, it won't show here. But what you can do is that you go to CPU2, boundaries, default. Will show you the whole CPU. But if you want this to be the whole new boundary, you say right click boundaries, you say new, and then you assign a part surface to it, which is the top we have just renamed. So there we go. So that's your whole CPU, and there's your top. Okay? Well, I don't want this, so I delete it. See, now the problem is that you don't see the top part of the CPU. You can just add it again here. Just clicking on it, and then add. Now there it is. Alright, that's not our problem. So let's save this again. Now we need a mesh. This is the important part. So let's go to operations, new mesh, automated mesh. You can create different meshes for each part, but I'm just gonna select all. This is for simplicity, and just create a mesh for the same mesh for every part. So I would like a surface measure, polyhedral measure, prism measure, sure, why not? We can assign 1 millimeter as the base size, 1 millimeter. Alright, and target surface size. This is the face size that measure aims to achieve in the absence of smaller mesh control. Let's say 50, or 50 is too small. Say 60, alright? 60 is good. Minimum surface size, I'm not going to touch these. You can read all of these in CFD forums, they're pretty helpful. Let's a number of prism layers. We will see what's a prism layer is in mesh scene. So let's make this 4. Prism layer stretching, this is, so we have assigned 4 layers of prism, right? So each layer will stretch according to the previous layer. So you have your first layer, the second layer will stretch 1.5 times the first one, and then so your third layer will stretch by the amount of 1.5 times the second layer. We don't need that much stretching. What we all need is like 1.3 or 1.2 even. That's fine. Total thickness, it's the total thickness of the prism layer. It's not quite, all of the total thickness are relative to the base, so whatever you assign here, the percentages show, the percentages are the percentages of the base size, okay? So 25 should be enough. Okay, the mesh density, I would like a slower growth factor. What growth factor is specifies rate of cell size transition from coarse to fine area. Alright, so I would like a slower one, 0.5. Well, let's make it 0.6. By the way, you don't have to play with these if your computer is not as strong as mine. I mean, I'm not boasting, but if your computer struggles with a base size of 1, you can just make it 3, and you'll be fine, doesn't matter. Target surface size, you can also make this like 70, 80. It's fine. It's just a tutorial, okay? Let's click part per part meshing, okay? You can make more than one, as I was saying, for like CPUs, for the bases, for the copper pile, for the waterway. But just for simplicity, I'm just creating a one operation. Alright, so serial, you don't need parallel meshing. You can create custom controls, volumetric controls, as I was saying. You can create a box around this CPU for better, finer mesh. And this is where you can do it. You just say volumetric control and select that box around it, which will not be in the regions. Just be careful about that. And yeah, we can make surface controls as well. We don't need, for example, we don't need prism mesh around the CPU. So what we can do is say surface control, select surfaces of CPUs, for example, okay, and then you go down, you go down here, control, prism layers, just say disabled, you don't need those. Alright, so here's our mesh, we will mesh it now. Let's run it. You can also run it from here. It may take a while, so let's see. So our mesh is done, and it looks something like this from the outside. It looks good, but what's important is its inner beauty, right? So in order to see its inner sides, see the quality of the mesh we did, we'll make a cross section through this plane, and then we can make cross section through here, just to see what's happening on the CPUs. And then this cross section will be to see the mesh inside the pipes. So how we're going to do that is that we have to drive parts. We'll drive a section plane. Okay, so our normal will be Y, the first one. Alright, so let's adjust this. You can adjust positioning by clicking the red line. And I'm just dragging it. So it's about in the middle. It looks fine. We don't want any displayer. So yeah, let's create one. And then make the normal X only. No, just make it Z, and then we'll create those later. And it's right in the middle. It looks fine as well. Yeah. Alright, so that's that. So now we have our mesh scene, right? What we have to do is assign these. So deselect all, and then just click these. Or you can just click on this and it will select all of it. So here's the mesh we did. So we don't really know if the cells are in good quality. So what we can do is create a scalar mesh. Scalar scene. Well, it's not a scene, it's just a displayer. So you right click, we're still in the mesh scene. You right click, say scalar, and then go to parts, select drive parts again. Our scalar field, we need to select the function, right? And so function will be cell, just write cell, cell quality. So there it is. This is our cell quality. So we have our prism layers. We didn't really need for the bases as well, the prism layer. Well, we really need it for the water pipe, but it's fine. It's just better. Transportation of information is better with prism layers. But our mesh looks pretty fine. I mean, it's not bad. It can be improved, but it's good for this purpose. I will sell, the amount of cells we have is 70,000. Nope, 703,000, my bad. It's a fine number. I mean, you can reduce it by just playing with these values over here. Base size, you can increase it, and everything else will be increased. So we have our mesh, we have our quality. Now, let's assign some boundary conditions, right? So let's go to waterway, boundaries. This will be, the inlet will be velocity inlet. Yeah. And let's make this static temperature of 35 Celsius. Velocity magnitude of 1 meter per second. Let's reduce it down to 0.1 meter per second. And then let's make this pressure outlet. Again, the same things. No, let's not touch pressure. Make it 35 Celsius. And then you don't have to play with these. They're fine. Alright, so that's that. You don't need any energy source. That is fine. Thermal specification, that's all good. Okay. We need to assign an ambient temperature of 35 degrees for each region here. So instead of assigning the heat source and the boundaries, alright, we'll make this convection. And our convection will be 0. However, our ambient temperature will be 35 degrees. We're trying to cool these CPUs in 35-degree environment, that's the case. And the CPU temperatures should be below 85 degrees Celsius. So we will repeat the exact same thing for CPU 1. You don't have any convection, alright. The ambient temperature is 35 Celsius. Heat transfer coefficient is 0. This is true for copper pipe. Let's make this convection. Ambient temperature is 35 degrees. And then heat transfer coefficient is 0. Water wave, let's do the same thing. Thermal specification, convection, alright. Ambient temperature is 35 degrees Celsius. Heat transfer coefficient is 0. Okay. So CPU 1 is 20 watts and CPU 2 is 15 watts. Let's assign those. CPU 2, total heat source, physics values, this is 15 watts. And then CPU 2, the same exact thing. The total heat source, and it's 20 watts. Alright, there we go. Let's save these again. Now we need to create a scalar scene to see what's going on. It would be a great idea to create drive parts of section that shows cross section in this plane, in this axis. We'll see. Let's do that. New parts section. Just drag this here, like approximately in the middle. Should be fine. Create that. Oops, no displayer. And then create that too. Hit create, and you have those. accidentally created this one. Delete this one. And then we have these, we have this one. Go to scalar scene, the scalar parts. We would like to see temperature profile for all of these. Alright, let's see. Let's say plane 4 or 5, and then plane 2, okay. We don't need plane 2. Say, select 4 or 5. We go to our scalar scene, so there it is. You can disable the outline. Let's select a scalar function, temperature. Alright. Let's put a vectorial displayer as well, just to see the flow in the pipe. And all we have to do is choose plane 1. Alright, so we have our velocity and temperature. Now, okay, to see, in order to see whether simulation reaches steady state, we have to monitor temperature. So we can do that by creating a report. Select element count, and then say maximum temperature. Field function temperature, and I would like to create a report for CPU1, let's say. CPU1 max Tmax. Alright. You can do this for every part. Let's do it for water wave as well. So CPU2 Tmax. CPU2. So while selecting these, do not choose parts. Alright. Because sometimes when you make changes for parts, these things get deleted. I mean, you have to choose parts again for each one of these reports, and that takes time. But in the regions, like any change you make here does not affect regions, okay? Unless you make changes in the regions, obviously. I would like to monitor the maximum temperature, max Tmax, waterway, water Tmax. Okay. Let's select waterway. That's great. Okay, you can just, yeah, let's select all of these, monitor and plot. I think I did too fast. Create monitor and plot from report, single plot, multiple plots. If you say multiple plots, so we'll just make multiple plots for each. So one plot for this, one plot for CPU2, one plot for this. Well, I would like to see all of these in a single plot. Okay, iteration. Let's make this Celsius, not Kelvin. Let's make these scalars smooth field, and then the scalar field should be in Celsius. It's better to understand, well, at least in my case. Alright, so okay, we're done. We can see our results now. Okay, and then if you would like to make a video out of the simulation, you can do this. So let's create a file. Alright, file is, let's name it pictures heat transfer. Yeah, ignore my desktop please, I'm sorry. And let's say update. So I'm in scalar scene right now. I opened attributes, I went to update, and then I would like to enable saved file. The iteration frequency, this means that for every iteration it will save a picture. this like significantly slows down your simulation. So I would like to make it 2. For each 2 iterations, it will save a hard copy. You can change the width and the height of your, the resolution of your hard copy. I'm not going to touch that. And then output directory. Where would you like to save your pictures? I would like to save it on heat transfer. No, pictures heat transfer. All right. Okay. So that's that. So now let's go to solvers. Okay. Here's your current number. Read about current number. It's important. Let's make it 50. 50 is fine. I mean, you can increase it furthermore, but let's make it 100. All right. And then stopping criteria. I would like to make it 50 first. If it does not get steady after 50, we can always increase it, or you can disable it, and it will go on forever until your computer explodes. All right. Okay. Okay. Cool. Now open this reports plot. Yes, we can now close these. The extra RAM. We're eating extra RAM. Okay, not necessary. And I'm gonna close this. Quit. And we can run. Save it. Let's run it. Let's see our scalar. Alright, wait. Here's the thing. The arrows are very fine. Also, since this is saving, we set Scalar-CCM to save for each 2 iterations. Whatever you can change the scene here, and whatever you have here will be saved. So adjust your scene accordingly, and it will save. So you can look at the pictures. So you see, so you can see how it changed. I changed the scene. So we can start over. Let's delete these. I would like to show you something else. So we have our vectors here, right? The colors are very same. The color, let's change the color bar. It should be better. And then the glimpses are very long. Let's make these 2. And then geometric spacing. Let's increase the spacing so they will be less. You can increase the length of it. Let's make it 4. Again, increase the spacing. Now you're much better. Again, let's make it 6 or even 10. Alright, much better. And increase the relative length. That's a bit too much, I think. Alright, there we go. Now the solution, I would like to delete the solution. What I do is just go up here, clear solution, say okay. Just put it into this position, save again, and let's run it. So my simulation is still running, but something weird just happened. I'm not sure why. Maybe because of the mesh we have created. It's not that detailed, but if you look at the residuals, went crazy for some reason after this point. There's an instability. I'm not sure why. Maybe because of the current number. But the point is that the reports plot on temperatures should be a straight line. So if we ignore this part, so it's going something like this, right? A parabolic in a parabolic way. It should be straightened out after a while, and there shouldn't be any significant changes between previous numbers, previous temperatures, and final temperatures. So yeah, let's stop this here, and I'll run it again and see if it does the same weird stuff. I will reduce the current number from the solvers coupled implicit to 50. Let's see what happens now. Let's save it again. I will delete the pictures too, and let's see what's gonna happen. So you guys kind of reached steady state, but it still has a way to go. But residuals are weird. I'm not sure why it's like this. I think the mesh quality is not that good. The results do make sense. Hottest temperatures at CPU1 and the lower temperatures are around CPU2. And yeah. Oh, I also changed the Courant number again. I reduced it to 5. Try it like that. I tried to increase cell number by just decreasing base size. So hopefully I was able to make you learn new things that you didn't know this tutorial. One last thing that I can show you is, let's say this one. Oh, you can just take the hard copy of this image, by the way. Just right click, or you can do it here. Just right click, say hard copy, and save it wherever you want. You can change the resolutions and all that. So the saved images are here. You can just scroll or just transfer these to a video editing software and just edit your video and make a video. So you can see the changes, what's happening for each 2 iterations. So yeah, this is it. Thanks for watching. Good luck with your simulations. I will try a new case and hopefully video it as soon as possible. Take care. Goodbye.